In this video, you will learn about rational square roots. Now, what is a square root? Well, a square root is basically the opposite of squaring something. So remember, when you square something, that means you're raising it to the second power, or in other words, you're multiplying it by itself. So for example, 0 squared would be 0 times 0, which would equal 0. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16, and etc. So a square root is the opposite of that. So the square root of 0, you're asking what squared gives you 0. Well, 0 squared is 0, so the square root of 0 is 0. The square root of 1, you're asking what squared gives me 1. And that's going to be 1, because 1 squared is 1. The square root of 4, you're asking what squared gives you 4. And that's going to be 2, because 2 squared is 4. The square root of 9, we're asking what squared gives you 9. That's going to be 3, because 3 squared, or 3 times 3, is 9. And then again, for the square root of 16, we're asking what squared gives you 16. And that's going to be 4, because 4 squared, or 4 times 4, is 16. So the square root is the inverse of squaring something. Now with radicals, or any sort of root, there are different parts of a radical. So the number up here is called your index. This sign is called your radical sign, and this number 4 on the inside is called your radicand. So with the square root, the index is an assumed 2. So if it's not written, the index is an assumed 2. Alright? So make sure you know the terms and make sure you understand that a square root does have an index, and the index is 2. You just don't need to write it. Okay, now we also need to be aware that when you take the square root of something, you technically have two different answers. For example, the square root of 1 would technically equal 1 or negative 1, because square root is asking what squared gives you 1. Well, 1 squared would equal 1, but also if you do negative 1 squared, we would also get 1 with that as well. So a square root technically has two different answers. If you have the square root of 4, the square root of 4 could be a positive 2 or a negative 2 for the same reason, because negative 2 squared could also equal positive 4, which is the number on the inside. Okay, square root of 9 could be 3 or negative 3, and this could keep going as well for square root of 16, 25, 36, etc. Now, we're typically only concerned with what is called the principal root, or the positive answer. So when it asks you for the square root of 1 or 4 or 9, just give the positive answer, or the principal root. Now, since we're on the conversation of negative numbers, what would happen if you took the square root of a negative number? So for example, a square root of negative 1. Well, what this is asking is what squared gives you negative 1? Well, you might think, okay, 1 could work, possibly, but 1 squared gives you a positive 1. So maybe we could try negative 1. Negative 1 squared would still be a positive 1, right? So nothing squared would give me a negative number, because when I square it, it doesn't matter if your number is positive or negative when you start, when you multiply it by itself, it always becomes positive. So what this means is that there is no real answer. So we say it's not real, or another term we can use would be imaginary. So if you have the square root of negative 4, that also is not real, because it's a square root of a negative number. And again, the square root of negative 9 is not real for the same reason. Now what if the negative's on the outside? So a negative and then square root of 9. Well, what you do is you treat square roots like exponents. So think of this as order of operations. The radical you can treat as an exponent. So we do the exponent first, and then this negative It's like a negative 1 being multiplied by the square root of 9. That's another way of writing the same thing. So we do the exponent first, or the radical in this case. Square root of 9 is 3. So negative 1 times 3, which is a negative 3. So when you do this, you don't need to go through all those steps. You can just see this negative square root of 9 and do the square root of 9 to get 3 and just make it negative after the fact. But the reason you do that is because of order of operations. So if you had a negative square root of 4, again, same thing. We take the square root of 4 first, which is 2, and then do the negative after, which would make it a negative 2. Next, we need to know what is called the product property of square roots. Now to illustrate this, let's say we had the square root of 4 times 25. Well, 4 times 25 is 100, so we have the square root of 100, which would be 10, because 10 squared is 100. Now, we could separate this square root of 4 times 25. I can break that apart as the square root of 4 times the square root of 25. So we have two different radicals, and the square root of 4 is asking what squared equals 4, and that's going to be 2. And then the square root of 25 is asking what squared gives me 25, which would be 5. So 2 times 5 would equal 10. So notice we get the same result either way. So the product property of square roots says that if you have the square root of a times b, that's equal to the square root of a times the square root of b. Or in other words, I can separate in two different radicals. And this property is helpful when I'm trying to simplify radicals. For example, if I had the square root of 196 and we're trying to simplify this, well, I can think of this as 4 times 49, and I could break that apart as two different radicals, the square root of 4 times the square root of 49, and the square root of 4 is 2, the square root of 49 is 7, so 2 times 7 would give me 14. So it's helpful when you're dealing with large radicals and you're trying to simplify. Next we have the square root of 3,136. Now this is a very large number, and what I can do is I can factor down 3,136 by writing this as a product of prime numbers. So I'm going to spare you the process, assuming you know how to do that. And when you do that, you're going to get 2 times 2 times 3 times 3 times 7 times 7. So assuming that we can get to that point, from here we can separate this as a product of three different radicals. So we can write that as the square root of 2 squared times the square root of 3 squared times the square root of 4 squared. And if we do each of these, the square root of 2 squared is the square root of 4, which would be 2. This would be 3, and this would be 4. So 2 times 3 times 4 would give me 24. So notice that this product property makes things a lot easier when we're trying to simplify and find the square root of something. So we've talked about the product property. Next we have what is called the quotient property, and this is for division. So the quotient property is basically the same thing as the product property, which says that I can separate a radical, a fraction, into two different radicals. So here, for example, if we were to do this the longer way, we would do 16 over 4, which is 4, so the square root of 4 would be 2. Okay, using the quotient property, I can simply think of this as the square root of 16 over the square root of 4, which would be 4 over 2, which is 2. So depending on your situation, you will want to know how to use the quotient property. So I guess in this case, they're both about the same length to do. It takes about the same amount of time. But there are cases when you want to know how to use the quotient property to make things a little bit quicker. So the quotient property, again, says that if you have the square root of a fraction, so the square root of a over b, that's equal to the square root of a over the square root of b. So I can split up this division problem into two different radicals. Now here's an example where we are using the quotient property. We're trying to find the square root of 1 over 4. So this one might not be as obvious to us if we did not use the quotient property. What I can do is I can separate this fraction into two different radicals, where I have the square root of 1 over the square root of 4. Well, the square root of 1 is 1, and the square root of 4 is 2, so my answer is going to be 1 over 2. Another example, we have the square root of 4 over 9. You can break this apart into two different radicals, where I have the square root of 4 over the square root of 9. The square root of 4 is 2, the square root of 9 is 3, so we have 2 over 3. One more example, we have the square root of 9 over 25. We can separate this into two different radicals, where I have the square root of 9 over the square root of 25. The square root of 9 is 3, the square root of 25 is 5, so my answer is 3 over 5.